Hello students, in this lecture we are going to learn about critical angle and total internal reflection. Okay, now let us understand this. Suppose we have a two medium 1 and medium 2. Now medium 2 is denser medium and medium 1 is a rarer medium. Okay, now what will happen? Suppose if a light is traveling in denser medium and strikes the surface, okay, at an angle I, what will happen? As per refraction law, what will do? The ray will bend away from the normal, right? Because it is traveling from denser to rarer, correct? So what will happen? And of course some part will be reflected back. So always some part will be reflected back and some part will be refracted in another medium. Now when you increase the angle, this angle of incidence, suppose I increase the angle like this, suppose this is my I1 or I2, so what will happen? This R will also increase. This is my R2, correct? And if we keep on increasing the angle of incidence in the denser medium, the angle of refraction also keeps on increasing. Okay, the only difference will be that the intensity of light, understand this point, the intensity of light will also decrease. When you increase the angle of incidence, the major part starts getting reflected and the minor part will be in refraction. So when the angle is small, majority refraction happens, minority reflection happens. But when you start increasing, the intensity of light decreases. It of course it is going away from the normal, but also the intensity of light is decreasing. So once when it reaches a certain angle, suppose let us say this I3, what will happen? Suppose this is my final, this is R3, correct? So at one point what will happen? If you keep on increasing the angle of incidence, your angle of refraction also keeps on increasing, and at one point this R3 will become 90 degree, correct? So this point when we have angle of refraction is what, 90 degree in rarer medium. So your this angle of incidence, this I3, is basically known as my critical angle, and we denote it as IC, critical angle, or some books it is also written as C. Anyway you can write. So angle of incidence is equal to critical angle when my angle of refraction becomes what, 90 degree. Now again at this point of time what will happen? Very small part is along this surface and majority of will be going through reflection, right? Now let us understand the relation between this critical angle and the refractive index, right? So suppose we have I am just drawing the critical angle IC. What is happening here? My refraction is what, at 90 degree, correct? This is my rarer medium, this is my denser medium, okay? This is my N2, this is my N1. So applying Snell's law, what we can write here? We can write N2 sine IC is equal to N1 sine R. Now we know that sine R is what? sin 90. So N2 sin IC is equal to N1 sin 90. Now we also know the sin 90 is 1. So N2 sin IC is equal to N1 and sin IC is equal to what? N1 by N2. Right? So this is my relationship between the refractive index of two mediums and the critical angle. Right? Now always remember this, the critical angle will always happen in the denser medium. It will not happen in a rarer medium. So this critical angle is always related with the denser medium. So if you want to find the refractive index of denser medium with respect to rarer medium, which is what? N2 by N1, it is equal to 1 upon sine critical angle. Because it is N1 by N2 here, so I have just make the reciprocal of sin IC. So this is one same relationship, but this is remembered as this only. Okay, so this is the relation between the refractive index of the denser medium with respect to the rarer medium in terms of critical angle. This is also written as how is 1 and 2, right? Now let us understand the factors on which the critical angle is dependent. Okay, we know the formula sin IC is equal to what? N1 by N2, where N2 is my refractive index of denser medium and N1 is what? The refractive index of a rarer medium. We can write the same thing in this way also, where this is the denser medium's refractive index with respect to the rarer medium. So my critical angle is basically what? Dependent on a refractive index, and we know that since they are reciprocal of each other, so if N decreases, my IC increases, and if it increases, it decreases. Simple, the relationship. Okay, so let us understand the two factors. Now the refractive index depends on wavelength of the light. Okay, and we know one formula, that N1 lambda 1 is equal to, by this formula we can say that if my wavelength increases, my refractive index decreases. So when lambda increases, my refractive index decreases, and when refractive index decreases, my critical angle increases. So there is a direct relationship between lambda and critical angle. So if wavelength increases, my critical angle also increases, and vice versa. If it decreases, this increases, this also decreases. Correct? So you can say that this is my, if violet light is there, for violet my IC is smaller. For red, IC is higher. Why? Because the wavelength of red is more than wavelength of violet light. Correct? Second factor is temperature. Oh, temperature also has a inverse relationship with the refractive index. If my temperature increases, my refractive index decreases, and when refractive index decreases, my critical angle increases. Similarly, if temperature decreases, refractive index increases and critical angle decreases. Correct? So these are the two factors on which my refractive index is dependent and critical angle is dependent on refractive index. Now you need to remember some values of critical angle for some medium. For example, for glass, my critical angle is 42, and for water my critical angle is approximately 49. These are all approx values. So for glass it is 42, and and for water it is 49. You need to just remember these two values. For rest, I think they will give in the question only. Okay, now we will talk about another topic, total internal reflection. We have already learnt about critical angle. Critical angle is the angle of incidence in denser medium for which the angle of refraction is equal to what? 90 degree. So basically we have three cases. One is when my angle of incidence is denser medium, this is rarer medium. I1 is what? Less than critical angle. So what will happen? It's simple. Some part will be what? Reflected back and majority will be refracted, and as you increase the angle of incidence, the ray will start moving away from the normal with a decreased intensity. Second case, when it is equal to IC. So when I is equal to IC, right? What will happen? Simple. My refracted ray will travel along the surface of the medium, and very less part, majority will be getting reflected back. Now what will happen when this my angle of incidence is more than critical angle? So what will happen? The whole ray, the whole light will be reflected back. Okay, and now it will reflect back with complete intensity, 100%. Very less chance of getting anything outside the medium, so it will reflect back with 100%. Even mirror cannot reflect with 100% intensity. So this is known as my total internal reflection. That's why it is known as total. Why a total word is? Total word is for total intensity. Whatever intensity with it is coming and striking the surface, it is reflecting back with the total original intensity. So that's why it is known as total internal reflection, and this will follow the law of reflection. If this is my I dash and this is R dash, I dash will be equal to R dash. Okay, so this reflection is better than the mirror. So our total internal reflection depends on two things. It will happen only when the first is my incident ray is traveling in denser medium. It will not happen when my incident ray is traveling in rarer medium. It will not happen. Only refraction will happen when it is traveling in a rarer medium. But when incident ray is traveling in denser medium, there is a chance of total internal reflection, and that chance is our second factor. Then we can say that I is greater than IC, critical angle. So my angle of incidence is greater than critical angle, then only the total internal reflection will take place. Okay, so these are the two factors you need to remember in the mind. First one is that the light will travel in denser medium and it will strike the surface with an angle which is greater than critical angle. Okay, let us understand the consequences of total internal reflection. where we can find this phenomenon useful, or what all happens naturally. So there are lots of things, but we will focus on two things. Okay, first is, we all know this term mirage, right? In desert area or in a hot area, we normally see this phenomenon. What is mirage? Let us understand. Mirage is basically getting an image of water on the surface where the water is not there. Okay, how it happens, let us understand this. Suppose this is my desert area, or suppose there is one object, or you can say one tree, right? Suppose there is one tree. Now what will happen? See, this is my hot area, desert area. So the temperature of the surface near to the temperature of the air near to the surface is more than it above surface above it. Okay, so if I just divide my whole thing into different layers, suppose I am dividing it like this. So this T1, T2, T3, T4. Now T1 is greater than T2, greater than T3, and greater than T4. Since temperature, what temperature does? It reduces the refractive index, they are inversely proportional. So we can say that my N1 will be less than N2, N4. Correct? So what will happen? If a light, suppose sun is there, okay, and if light goes like this, and if it starts moving towards this, right, what will happen? It is going from a lower temperature to higher temperature. It means it is going from higher refractive index to lower refractive index, denser to rarer. So what will happen? It will move away from the normal. Correct? Again at this point, what will happen? It will again move away from the normal. And if the critical angle, if this angle is more than critical angle, then what will happen? It will goes like this. It will happen total internal reflection, right? And if I am here, then I can see the image of this tree somewhere here downward. So what I will be getting? I will be getting a reflection of this tree, suppose like this, right? So, and reflection happens when basically what? If a water is there, correct? So it seems that there is a water around this tree, and hence, and that's why the reflection is happening. Even if you travel on a very sunny day, hot day, on a road, you will see at some distance the water is there. That water is basically what? The image formed by this total internal reflection of clouds in the sky. So light is getting reflected by that cloud, and it is getting totally internal reflected, and the image of cloud is on the road, and we can see the water on the road, and but there is no water when you go nearby that place. So this is known as my mirage. Correct? The second important thing is optical fiber. Nowadays this optical fiber is very much in trend. Okay, your telephone lines, your internet cables, all are basically what? An optical fiber. So they use the phenomenon of total internal reflection. So it is basically what? An insulated wire where the light enters at an angle which is more than critical angle, and since the inner surface is very shining, so it gets reflected back like this and travels very fast without losing any energy. Since I am saying without losing any energy, but there is a loss of some energy due to absorption of light by this material which is made up of this wire. Okay, and but there is a very minimal loss of energy as compared to any other medium. Okay, so this optical fiber is also based on the phenomenon which is known as total internal reflection. So these two phenomenon you can say are important with respect to total internal reflection.